Imagine this: Earth's invisible shield, the magnetic field that has protected life for billions of years, is quietly fading. It's not a sudden catastrophe, but a slow, relentless decline that's accelerating in ways scientists are only now fully grasping. As of September 25th, 2025, data from the latest World Magnetic Model, WMM 2025, released by NOAA just last December, shows the field has weakened by about 10% over the past 160 years, with the trend continuing unabated. This isn't just some abstract scientific curiosity. It's reshaping how we navigate the planet, how satellites operate, and even how we prepare for cosmic threats from beyond our solar system. But what if this weakening isn't isolated? What if distant galaxies like our nearest neighbor Andromeda could play a role in these changes? Stick with me through this journey, because by the end, you'll see why researchers are rethinking everything from space weather to the very fabric of our cosmic connections. We'll dive into the data, the theories, and the mind-bending possibilities that could redefine our place in the universe. Let's start with the basics to build a solid foundation. Earth's magnetic field acts like a colossal bubble, generated deep within the planet's molten outer core, where swirling iron and nickel create electric currents that, in turn, produce magnetism. This dynamo effect has been Earth's guardian against the harsh solar wind, streams of charged particles blasting from the sun that could strip away our atmosphere if left unchecked. But recent observations confirm the field is getting weaker, and it's not uniform. The magnetic North Pole, for instance, is racing towards Siberia at an astonishing 50 kilometers per year, far faster than historical rates. This shift isn't new. Earth's poles have flipped hundreds of times in geological history, with the last full reversal occurring about 780,000 years ago. During these flips, the field weakens dramatically, sometimes dropping to just 10% of its normal strength, leaving the planet vulnerable for thousands of years. Now picture this vulnerability amplified by current events. As of mid-2025, NASA's monitoring reveals the South Atlantic Anomaly, SAA, a massive dent in the magnetic field stretching from South America to Southwest Africa, has grown even larger. This region, where the field is up to 30% weaker than elsewhere, allows more solar and cosmic radiation to penetrate, posing risks to satellites and astronauts. In July 2025, Science Alert reported that the SAA is expanding westward at about 20 kilometers per year, and its intensity continues to dip. Satellites passing through it experience glitches, and even ground-based systems feel the effects. But why is this happening now? Scientists point to irregularities in the core's flow, including a dense rock structure beneath Africa that's disrupting the dynamo's balance. This isn't science fiction, it's real-time geophysics, and it's forcing updates to navigation systems worldwide, from GPS to aviation charts. But hold on, there's more to this story that will keep you hooked. What if these earthly changes are intertwined with forces from far beyond our solar system? Enter the Andromeda Galaxy, our cosmic sibling, just 2.5 million light-years away. In June 2025, NASA's Chandra X-ray Observatory released stunning new composite images of Andromeda, M31, combining data from multiple telescopes to reveal its supermassive black hole, star clusters, and vast plasma halo. These observations show Andromeda isn't a static neighbor. It's a dynamic powerhouse with over 1 trillion stars, including potential magnetars and black hole activity that could emit powerful transients. While no direct signal from Andromeda has rattled Earth recently, that would defy physics given the distance, the idea sparks fascinating speculation. What if intergalactic magnetic fields, threading through the cosmic web, could subtly influence our planet during periods of weakened defenses? We'll explore that hypothesis step by step, but first let's ground it in what's actually happening. Recent magnetometer data from 2025 paints a picture of a restless magnetosphere. NOAA's network, ESA's swarm satellites, and even quantum sensors at research facilities have logged spikes during solar quiet periods, times when the sun isn't flaring. For example, in April 2025, a minor geomagnetic disturbance was linked to the SAA's expansion, causing brief navigation glitches over the Atlantic. These aren't impossible events, but they highlight how our thinning shield amplifies even subtle cosmic inputs. The timing often aligns with solar wind variations, but some anomalies suggest broader influences. Imagine Earth's magnetosphere as a drum. The sun beats it daily, but distant cosmic rhythms could add faint echoes if the conditions are right. This brings us to a historical precedent that will blow your mind: the 2004 magnetar flare. On December 27, 2004, a magnetar named SGR 1806-20, located 50,000 light-years away in our own Milky Way, unleashed a gamma-ray burst so intense it ionized Earth's upper atmosphere and caused a measurable ripple in the magnetosphere. For several minutes, ground-based sensors detected pulses matching the magnetar's 7.5-second rotation period, like hearing a distant star's heartbeat through our planet's field. This bell-ringing effect proved that extraterrestrial sources can vibrate Earth's magnetic bubble, even from galactic distances. Fast forward to 2025, with advanced quantum sensors detecting shifts as small as femtoslas, we're picking up whispers that older tech missed. Could something similar, scaled up, happen from Andromeda? Hypothetically, yes, if a massive event there timed perfectly with intergalactic pathways. Let's unpack that hypothesis with the latest data. First, the resonance trigger idea. Earth's magnetosphere has natural frequencies around 0.1 to 10 Hz, where even weak inputs can amplify into detectable spikes. Think of an opera singer shattering glass, not with volume, but precise pitch. Recent studies from 2025, including those using GRACE satellites, showed dynamic shifts in the lower mantle that could alter these frequencies. If a distant pulse from Andromeda matched one, it might ring our field. But remember, any signal from Andromeda today left 2.5 million years ago, so this is pure speculation, not observation. Second, intergalactic magnetic bridges. Galaxies aren't isolated. They're connected by vast filaments of magnetized plasma in the cosmic web. In 2025, observations of fast radio bursts, FRBs, traversing these filaments reveal they can carry coherent signals over millions of light-years without dispersing. Andromeda's plasma halo, extending 500,000 light-years, could channel such energy. Recent Hubble and Gaia data from June 2025 revised Andromeda's mass downward and pegged the Milky Way-Andromeda collision odds at 50-50 within 10 billion years, hinting at ongoing gravitational interactions that might align these filaments. Third, our quantum sensor era. As of 2025, atomic and AI-enhanced magnetometers are revolutionizing detection. These tools flagged anomalies during the February 2023 magnetic storm, but 2025 data shows even quieter events. For instance, in August 2025, Sustainability Times reported terrifying forces in the SAA, linking it to worldwide shifts. This sensitivity means we're uncovering patterns that suggest Earth's field interacts with the broader universe more than previously thought. To engage you further, let's simplify with analogies. Earth's magnetosphere is like a cosmic drum. The sun drums daily rhythms, but a far-off thunderclap from a magnetar flare or black hole burst could send vibrations if tuned right. In Andromeda, potential sources abound. Its central black hole, 200 million solar masses, shows dormant but variable activity. A 2025 study in astronomy and astrophysics noted periodic X-ray variations possibly tied to dark matter. Magnetars, Andromeda likely hosts millions, and a flare could propagate via filaments. Dark matter halos add mystery. 2025 FRB data hints at modulated plasma flows. Why does this matter in 2025? Our tech relies on magnetic stability. GPS, power grids, and even high-frequency trading could glitch from subtle shifts. During solar cycle 25's peak, extending into 2025, flares compound risks. A weakened field plus solar storms echoes historical events like the 1859 Carrington event. But today, it'd devastate infrastructure. Defense sectors are alert. Distinguishing natural anomalies from threats is crucial. But don't stop here. The real twist awaits. What if these aren't one-offs? 2025 data suggests recurring patterns, like SAA-linked radiation spikes. Hypothetically, if intergalactic filaments regularly channel energy, Earth might be part of a galactic network. To test, correlate magnetometer data with Andromeda observations, simulate filament propagation, check archives for matches. Reproducibility is key. Multiple teams verifying builds credibility. As we wrap up, remember, this exploration blends fact with informed speculation. Earth's field is weakening, Andromeda is active, and cosmic connections are real, if subtle. But a second window. Recent X posts hint at anomalies toward other galaxies, suggesting systematic phenomena. Stay tuned. Subscribe for more. Like if this intrigued you, and watch till the end next time for breakthroughs that could change everything.